ओके वेलकम ब्याक। आज हामी बिसिए फोर्थ सेमेस्टरको नोट पढ्नेछौँ। आज हामी न्युमेरिकल मेथड पढ्नेछौँ। कम्प्लिट नोट छ, यो नोट पढ्छ। सुरुमा रहेको छ सिम्सन 3/8 rule setting n is equal to 3 in a general formula. We observe all the difference higher then the third will become 0 and we obtain x3 y dx 3 equal to 3 y o 3 y o x 3 x by 2 similarly y dx. Composite, the trapezoidal rule is the area to be integrated is large. The trapezoidal rule can be improved by dividing the interval AB into the number of small interval and applying the rule. The sum of area of all the sub-interval is integrated at the interval A, B. This approach is known as a composite multi-segment approach. A is equal to x0, x1, x2, x one minus one x n h is equal to b minus a by n x1 0 x0 mean 1 h I 0 I 2 I 3 as of the sub interval within the node x1 and x0 is given by the total segment 2 is its general form of the composite trapezoidal. Apply the Simpson rule and 1 by 2 calculate. Which is the general composite form. Applying the Simpson 1 by 3 rule to calculate 1 by sin dx with k is equal to even the given equation sin dx with k is equal to 3k x by the 3 x plus s by a k x by x plus 1 x by 2 x 0 x plus 1 k o plus 0 into x2 plus 1 x 0 x 6 0.5 0.8 x2 x plus 1 x3 1 x for 0.866 0.50. We know that y dx has 3y0 whole 4y1 plus 2y2 4y3 2y4 4y5 4y6 so x by 3 into 6 0 plus 4 into 5 2 into 0 plus 8 6 6 8 into 1 2 into 0 plus 8 6 6 into 0 4 into 0.5 plus 0 11 minus 4 6 4 1 1.8 0.006 Gaussian integration for x is equal to x minus 1, we consider the first order polynomial as x 0, a1 x, a2 x square, a3 x cube, a x fx dx 1 by x, a0 plus a1 x, a2 x square plus a3 x cube dx, a0 x, a1 x square by 2, a3 x cube by 3, a3 x square by 4, f dx and x0 is equal to given formula is A is equal to from equation first C1 plus C2 C1 C1 C2 C2 C1 solving the four instantaneous equation is C1 is equal to C2 C2 is equal to 1 x is equal to 1 by B3 x1 1 plus B3 minus 0.077350 positive 0 plus 5773502 hence 1 by 1 minus 1 fx dx is equal to fx c2 fx2 m by b3 plus m by here we use the 2 point d1 and d2 so it is called the 2 point quadratic formula. We can also deduct for the higher point for the end point of the generalized formula in f1 x dx is equal to for n is equal to 3 n is equal to c2 c3 x1 x2 x3 compute the integral using the Gaussian 2 point formula a is equal to x2 to z1 z2 thus x1 b minus a per into z1 plus b plus a by 2 2 into minus 0.57735 plus 0 minus 1 1 minus 1.5 b minus a by 2 z to b plus a by 2 2 into 0.57735 plus 0 now b minus a by 2 compute the following integral formula using the Gaussian 3 point formula using the Gaussian 3 point formula is given by f is equal to tx b is equal to fx c2 e fx c3 c3 f ex f ex2 0.0778 fx3 f cx1 c2 and cf x d square Robin's integration. This Robin algorithm produces the triangular area of the number all which are numerical estimate of the definite integral. The array is denoted by the notation f is equal to 0. The element of the matrix are computed by row in order to indicate in the figure the circle of the number indicate in order of the computerials and the arrow indicated and the dependency of the element and element if the head depend on the element of the tail in the first column of this matrix contain the eliminate of the integral often of the recursive trapezoidal formula with the decreasing value of keep slice explicitly r and 0 is the result of applying the trapezoidal within the 2n equal sub interval. The first term r00 is obtained by just with the trapezoidal. Similarly, r10 is obtained with the trapezoidal and the element into the column represent the trapezoidal rule as1 and as2 as4 they are can be evaluated recursively r0 as2 fa plus fb r0 I10 where b minus h k r I g equation 2 is called the Roberts integration formula. Compute the Roberts integration estimate r22 for r0 s2 f a f b 1 by 2 1 plus 1 by 2 0.75 r1000 h1 h e r10 b minus a 1 2 is got a2 a2 a3 a plus e k h I 3 s2 plus 3 s4 R2 110 0.783331 by 4 1 by 1.5 into 1.75 Rn or to the value error value approximate value 0.69314710 0.6900 solution for the ordinary differential equation mathematical model which uses the different calculus to express the relationship between the variable are known as the differential equation. The differential equation may appear in the different form number independent variable. The quantity being differentiated is called a different dependent variable and the quantity with respect to the dependent variable is differentiated is called independent variable. If there is an independent variable the equation is called the ordinary equation. Of there is more than independent variable the equation is called the partial differential equation. Dv by dt minus k by m b square dm by dt minus km 0 ordinary dv by d square f x y partial differential equation. Order of the equation. The order of the differential equation is the highest derivative of that appear in the equation. When the equation only contain the first derivative, it is the first order differential equation. If the highest derivative is the second derivative, then the equation is called the second derivable equation. Dy by dx f x y the order one y is second x x y double order two m d square y m d the x dy dt plus ky order two a degree of equation. The degree of differential equation is the power of the highest order of the derivative. X y1 x2 y1 2 y3 degree first order second y1 x by degree second order third initial value problem versus the boundary value problem. The solution of an ordinary differential equation requires the auxiliary condition for the n order equation in the n condition are required. All the condition are visualizes the same value of the independent variable, then the problem is called initial value problem. Example, e n y 1 x square plus y square given y is 0. The condition are known as the differential value of the independent variable, usually at the extreme point of boundary system. Then the problem is known as the boundary value problem. Solving the initial value problems, Taylor series we express with the expansion of the function y(x) that the point x is equal to x 0 using the Taylor series expansion xy is equal to x0 x0 y1 x0 x0 y1 1 0. The solve the other condition x is equal to 1 when x0 y1 x square plus y square 2x plus 2y1 2 plus 2y d1 y d1 dy by dx 2 plus 2 x d1. Substituting the value in the Taylor series x is equal to y0 n plus 2 minus 1 3 plus 2 2 minus 1 into 6 2 minus 1 by 3 1 plus 3 6 by 2 plus 6 by 6 1 plus 3 by plus 3 plus 1 8 2 y1 x square plus y square power x is equal to 2.05 y 10 x square plus y square 2x 2 y1 2 2 plus 2 y d1 d square y dy by dx 2 plus 2y 1 square x is equal to 0 and y is equal to 1. Mm, mm, y1 2 into 0 plus 2 into 2 into 1 is equal to 2 plus 2 into 1 plus 2 into 2 plus 2 into 1 is square. Substitution y0 x minus x0 y1 0 x minus x0 y1 0 0 x minus x0 y0 1 2 0.25 minus 0 into 1 0.25 minus 0 into 2 0.25 into 2 into 8 by 3. Now, Picard method consider the differential equation dy by dx fxy. We can integrate this equation to obtain the solution into the interval x0 x dy by dx y is equal to y minus 0 y2 y minus 0. Since y appear under the integral sign of the right side of the integration cannot be performed, the dependent variable y should be replaced by either the constant or fx. Since we know that the initial value x0 may we use this in the first approximation to the solution, the result can be used on the right hand side to obtain the next approximation. Generally, this equation is called the Picard method. Solve the equation using the Picard method. आजलाई यति नै फेरि भोलि हामी पढ्नेछौँ 10 मिनट भयो